All right, so today, this is why I don't like these. All right, so today we're going to work on solving quadratic equations. And we're going to use a specific method called completing the square. This particular method is used as you sort of travel up the mathematics chain of difficult classes. So since this is an elementary algebra class and completing the square is used in intermediate, it's used in college algebra, it's used in analysis classes. So I don't know where you're going in terms of what math you're going to sort of end up at, but I did want to make sure that we went over this particular process as it becomes very important in later math classes. Okay. So this comes from perfect square trinomials. Remember that if you have a quantity such as x plus b, and we're going to square it, that this ends up as x plus b times x plus b, or x squared plus bx plus another bx plus b squared, or x squared plus 2bx plus b squared. Similarly, if you have an x minus b squared, that's going to be an x squared minus bx plus b squared. For either x plus b squared or x minus b squared, yep. If I take the 2b, which is the middle term, fudge. If I take the 2b, which is the middle term, and I divide it by 2 and square it, that's always going to equal the n term, b squared. This idea is what we used to complete the square. So if we're given an x squared plus bx, if we take this coefficient of x and divide it by 2 and square it, we will have completed the square. That is x squared plus bx plus b over 2 squared is equal to x plus b over 2 squared. I'm not adding an x anywhere. Can I show you a couple examples and we can see if it, with some numbers? Okay. All right. Okay. So we're going to be given, let's say, an x squared plus 6x. And the idea here is that we'll start with the x squared plus 6x. But we're going to add in some number to complete the square. Well, it's going to be 6 over 2, and then we're going to square it. So what is half of 6? So this is x squared plus 6x plus 9, which is going to be the same as x plus 6 over 2 squared. Correct. This will only work for perfect squares. So what if you were given x squared minus 14x? How could you complete the square? And you're going to get what? Hold on. Not going to be 49. It is a plus 49 for the trinomial. But when you write it as a perfect square, it's going to be x minus 7 squared. Still doing okay? Okay. So given an a squared minus 5a, complete the square. Divide and square. Going to be a negative 5 over 2. You want to keep the sign that was here. And when we square that, what are we going to get? No, square it. That would be 25 over 4. So this would be an a squared minus 5a plus 25 over 4, which is going to be a minus 5 over 2 squared. One more? Okay. Completing the square? There's probably different ways to learn this if you've had different instructors. I'm just really laying a very basic foundation right now. We're about to go a little ballistic here. Okay, given m squared minus 9m, we want to say complete the square. I'm a little bit ahead of myself. M squared minus 9m plus some unknown amount. Would be a negative 9 over 2 that I'm going to square. M squared minus 9m plus, yep, an 81 over 4. Where? No, because it would have been a negative times a negative. When you square it, it's always going to be positive. Because it's negative times a negative, which is positive, or a positive. Good? Yep, m minus 9 over 2, quantity squared. All right, so now we want to use completing the square, specific to solve equations, quadratic equations. Let me preface this by saying, if asked to use this method, you must demonstrate this method. I am checking or testing to see if you can complete the square. This is not a solve it any way you want to kind of thing. I am literally checking a skill. Okay? All right. So here we go. Yep. All right. Do you see how the left-hand side is almost exactly what we were doing in the previous 4 examples? So we're going to do an x squared minus 8x plus some number. And we're going to set it equal to 4. But because this is an equation, whatever we add on the left side, we're also going to have to add that on the right side. Negative 16 or positive 16? There you go. So we are adding 16 to both of these guys. That means, sorry, the 2 you mean? It would be 64 over 4, which is 16. 8 squared is 64. So if you square it first, make sure you're squaring and not just multiplying by 2. Okay? Now, from what we were just doing, we know that x squared minus 8x plus 16 can be written as x minus 4 squared. And 4 plus 16 is 20. Okay? Yes, it's the number that you want for inside the parentheses. So the square bit goes up here, and this interior part is what goes down below. Summer, I heard you say, oh. What do you see here? No. What? Okay, so what we're looking at here is a perfect square that's equal to 20. Okay? Okay. Yep. If I were to FOIL this out and add stuff over, I can get back to this step, and then I can get back to this step, right? But I don't want to do that. I mean, that's a nice way to check to make sure that things are working and that you've got correct numbers. What I want to do right here is say if I have x minus 4 quantity squared equal to 20, I can, like we were doing yesterday, take the square root of the left side and the square root of the right side. And now I have x minus 4 is equal to the square root of 20. So I have 4 plus square root of 20. Can you break down 20? Yeah, 5 and 4. Since I have a pair of 2's, they can come outside. The 5 does not have a pair, so it stays on. Oops, this would be a plus or minus. I'm sorry, Ryan, I don't know what that question means. Correct. The square root is always a positive solution and a negative solution. I have to consider both possibilities. All right, second example, same process, slight twist. Here we want to solve an x squared minus 12x minus 3 equal to 0 using completing the square. Every other time we've completed the square, we've only focused on having these first two terms, right? So in order to keep that, I'm going to do x squared minus 12x, and I'm going to add 3 to both sides so that it looks like it did before. So now when I add both sides, it's going to be a negative 12 over 2 squared. Negative 12 over 2 is 6. And when I square a 6, I get a 36. So I will have x minus 6 squared is equal to 39. Now that this is a perfect square, we'll take the square root of both sides. So x minus 6 is a positive negative 39. I'm going to add 6 to both sides. I do need to figure out if 39 breaks down. "39 only breaks into 3 times 13, so it's not going to break down there. How we doing? You all right, Ryan? Okay. All right. Do you want another practice problem like this? Okay. All right, what are you going to do? Which is what? Square root. No, not quite. We want to move that 5 over, so we're going to subtract 5 from both sides. Negative 5 plus or minus the square root of 29. So negative 5 plus the square root of 29, or x is equal to negative 5 minus the square root of 29. Now, 29 is a prime number, so it won't break down. This one, most of the time, the program asks you for 2 separate answers, which is why I separate them. Now, if you're writing an answer for me, like if we were in a regular classroom and it was paper and pencil, this would be fine for me, the plus or minus there. But, okay, yeah. Yeah, there is in your math palette, there is an option for a square root. It shows up on the, I believe, right-hand side in a little tools bar. And you just need to choose that. Okay? All right. So there's one more type of example here that I need to make sure you see. And this is when the leading coefficient is not a 1. Go ahead. Yep, you want to subtract 8 over from both sides first. We don't want to take out a 3x, but we do want to divide everything by a 3. Because if I eliminate that coefficient, right? Yeah, we're going to have, the thing about this is oftentimes you get some really gnarly fractions. So I rely, and I say pull out your calculator at that point, right? So we're going to have a negative 8 over 2 squared, which we're going to be adding to both sides. Because we always add, we add half of this linear coefficient squared. So I'm going to do a negative 8/3 using my fraction button. And then I'm going to add 16. And I get an x minus 4 quantity squared is equal to 40 over 3. Now I need to take the square root of both sides. Summer, you're not showing up. Can you hold? There you go. Sorry, what goes where? You're good. Wait, Summer, talk again. Yep. Yes. I actually put it below, but yep. And then the perfect square trinomial here would be x minus 4 squared on the left-hand side. And then on the right-hand side, I used my calculator to do a negative 8/3 plus 16. Which gives me 40 over 3. Okay. All right, Ryan, it's not just one step. You need to be able to do several things. So negative 8 over 3, I've typed it in as a fraction. It's the ABC button. Then I'm adding 16, and I'm hitting enter. The calculator will give you the mixed number. You need to be able to turn that into the improper fraction. You can do that in your head, or you can use the second key and that fraction button again. Do you see above the fraction button? Do you see how it goes ABC to DE there? That switches between mixed number and improper fraction. Okay. All right, so now I need to take plus or minus the square root of 40 over 3, adding 4 to both sides. I get 4 plus or minus the square root of 40 over 3. And as we talked about before, I can't leave this as the square root of 40 over 3. I need to multiply both the top and the bottom by the square root of 3. So I have 4 plus or minus the square root of 120 over the square root of 9. That's just a 3. Now I have to see if the 120 breaks down. 2 times 60, 2 times 30, 2 times 15, 3 times, okay. So I only have a pair of 2s. Ack! 4 plus or minus 2 square roots of 30 over 3. That would be my exact answer. Yes, Ryan. Yeah, that one was hard in the last couple of steps. Yeah. Nope. Part of that is from the day you missed. Yep. You can't divide by a square root, so you got to multiply both the numerator and the denominator by the denominator. Square root of 120 over the square root of 9. The square root of 9 is 3. So we end up with the square root of 120 over 3. And then we've got to break down the square root of 120. Which is 2 times 2 times 2 times 3 times 5. For every pair, I can pull out 1. And since I have a pair of 2s, I can pull 1 2 out, leaving me with a 2 times 3 times 5 underneath the square root. That's a 30. And the 2 can now come outside of the square root. Where did you get lost? The break, it's the square root of 120. Okay? So you have to simplify the square root of 120. Mhm, mhm. Yes. Now, go ahead. Yes. Nope, you do that multiplication out because they didn't have pairs. So the 2, the 3, and the 5 that didn't have a pair, you can multiply back together. Yep, over 3. And then it's also a 2 minus square root of 30 over 3. Nope, no, no. 4 plus or minus. Square roots of 30 over 3. Okay, you got it. Remember, it's a square root, so you're going to have both the positive answer and the negative answer. Okay, so it's the 4 plus all that, and it's the 4 minus all that. Okay. All right, it's a rough one, no doubt about it. All right. So, any last minute questions for me? Okay. Yep. Yes. This assignment is due Monday.